Hello, and welcome to today's webinar, Airport and Airline RFID Myths Debunked. RFID use has been growing in the airport and airline market as customers seek solutions to improve customer satisfaction, reduce costs associated with mishandled bags, and respond to industry's best practices. The goal of this webinar is to address many common misconceptions about RFID and to demystify the technology. My name is Lisa Shaw, and I'll be your moderator throughout today's webinar. I work on the marketing team here at SICK, and I'm excited to be hosting today's session. I'm also pleased to introduce today's speakers, Tom Gebler from SICK and Mark Summers from Avery Dennison. Tom is the account director for airport systems at SICK, and he has over 30 years of experience in automatic identification, data collection, and automation. And Mark Summers, the Market Development Manager for RFID Aviation at Avery Dennison, has worked in various capacities for the industry's prominent system integrators, primarily within the business development and program management disciplines. Before we get started, I want to share that a recording of this webinar will be emailed to you following today's presentation. Also, feel free to ask questions at any time during today's presentation by typing your questions into the Q&A section in your control panel, which is on the right-hand side of your screen. Also, we will be asking a few poll questions throughout today's presentation, so please keep your control panel open in order to see the questions. Now I want to turn our time over to our presenters, the real reason you are here. Tom and Mark, please take it away.
Thanks, Lisa, and good morning, good afternoon, good evening to everyone. My thanks to Lisa and SICK, our appreciation to them for participating in this webinar. So with help from Tom and his generous offer to share his desktop, we can move on. I will present today in two parts. First, I will present and discuss the facts and their impact on baggage tracking. And secondly, we will address the myths and assumptions that have circulated and frankly may have prevented RFID from further adoption. So let's get that story straight. One more note before we begin. We acknowledge that the data being presented is from 2019, a time and place that has been challenged with the current global crisis we are dealing with. Our industry will return, I'm sure, with a renewed strength and harmony. Now is the time for all of us to work together and plan for this future. So Tom, if we can move on. So we're going to go ahead and present some facts and figures here, and some quite large numbers. Did you get the advance here?
Yeah.
Murphy's Law. There we go. Thank you, sir. So some large numbers we're putting up here. First of all, the 5.5 billion. Obviously we probably won't see this number in 2023. But we can certainly say that the industry will grow, and most likely we are, set back a couple of years. But growth is inevitable, if for no other reason than a larger traveling public. So no doubt that we will see continued growth in passenger numbers, even from the 2019 benchmark. Other big number is 27 million lost bags, and this presents a loss ratio for 6 bags for every 1,000 bags. But the real story here, I think, is that large number, 27 million bags, which according to CETA, the next panel on the right side, costs the industry over $3 billion, will cost it $3 billion for the next 5 years or so. And if we can put some sort of perspective, that number, $3 billion, is roughly equal to 32 Airbus A320s, or essentially another mid-sized airline. So again, please focus on the actual relative numbers here, and we can move on. So despite all of our efforts to remove baggage handling complaints, it's still an image problem from a customer satisfaction viewpoint. So they're saying here that among the most complained about items is still baggage. Another key metric we're presenting here is coming from Delta, who uses RFID system-wide, sees an improvement to moving baggage from check all the way to plane side. Many downstream benefits occur through this metric of 16%, and we'll see that in the benefits discussion a little bit later, in more detail. And we get a statistic from IATA that in this age of real-time data, the expectation is immediate information. The vast majority of us want real-time information at 85%. Next slide, Tom. So within the community that we that are the airlines of the world, and that is IATA, the nagging issue of baggage mishandling is being addressed with a formal approach in the form of resolutions and recommended practices. So the industry says, let's do something about removing this old and chronic issue. And I want to key in on the highlight that we've got here in blue, that unanimously, the IATA board unanimously, or the board unanimously resolved to support this initiative to go forward with RFID. Next, Tom. So this is where it all kind of comes together, why RFID specifically proves itself. And so let's look at these one by one. So under the head of cost control, we're seeing baggage handling system throughput increases of up to 18%. We saw that statistic coming out of the Delta system. We're seeing ramp loading times cut by 4 minutes per aircraft turn, which is significant. We're seeing that also creates one less full-time employee needed per aircraft turn. So you might need 4 or 5 people to load the aircraft with baggage. We're seeing it lessened by 1 person. Here's an interesting one regarding cost control. The employee injury rate has been reduced by up to 21%, and that's mainly due to ergonomic purposes or ergonomic reasons. If someone handles a bag less, doesn't need to shoot the bag with a handheld scanner for barcode, then there's certain injuries that can be reduced. And then moving to the other cost control items, IROPS recovery costs can be cut by up to 51%. And how can we say that? How does that actually happen? And the answer is, if we have IROPS and weather pretty much destroys a fortress hub, and we've got bags that are misconnecting all over the place, we have piles of bags within the bag room itself. It takes quite a while to find a connecting bag in a pile of 300 bags. Whereas if we use RFID technology, we can pretty much locate a bag in a very short amount of time within that large pile. The mishandled rates, which is our initial target, have been reduced by up to 13%. And then cost control can come in the form of reduced acquisition costs and recurring costs for the actual hardware that we use. An interesting thing seems to be happening with regard to the revenue side as well. So good stories here. Potentially this could result in increased checked-in baggage where we have baggage fees, and I'll talk about that in just a second in terms of the impact of ancillary revenue. But if passengers have an increased confidence in knowing where their bag is at any given moment, they're more inclined to check the bag itself, and we can say that pretty definitively. Many of us are actual business travelers, and why indeed do we avoid checked bags? There could be potentially a lift market share for those companies that do use RFID as opposed to those who don't, pretty much because they're aware of the fact that their bags will show up, or at least they'll be known in terms of their location, wherever it is that they're traveling to. And then a far-reaching revenue benefit could mean the addition of aircraft cycles. So if we look back on some of those metrics we talked about before about cutting ramp loading time by 4 minutes and those sorts of things, we could actually accumulate 30 to 40 minutes time gained throughout the course of a day and potentially have an additional aircraft cycle. The next slide, Tom. So I want to emphasize issues around cost with this slide for deployment, for operation, and for expansion. Let's look in particular at the fact that RFID is a complementary and supportive technology to existing barcode optical systems. It doesn't have to be a full replacement, rather an added component that pays for itself in a matter of months. And Tom will address more of this in his segment, but the important thing on this particular slide is to key in on the interoperable interoperability and the complementary capability of RFID with existing optical systems. And the next slide. So we talked about IATA going forward with resolutions and recommended practices surrounding RFID. And so why did they suggest RFID in particular? And this matrix that appears on this slide is particularly compelling. Using key metrics and data points like line of sight, range, singulation, and others, we compare RFID to other reading technologies. So looking at this chart, RFID presents an opportunity for best results. So you can see that the boxes highlighted in the medium blue color indicate where RFID is the clear winner. So these are results that occurred after several tests and trials and proof of concept. So this is pretty firm information. The next slide, Tom. So I alluded to the ancillary revenue component of this story. And so the impact of ancillary revenue is indisputable when it comes to airline profitability. Baggage fees have become a key element in ancillary revenue contribution. So growth here is obvious. And that I don't feel is going to change as we emerge from the current crisis. So looking at this slide, this is pretty much North America centric, but pretty much demonstrates the point that ancillary revenue, particularly baggage fees, are an important part of the profitability. And I'll move on to the next slide, Tom, to further this point. It is, baggage fees, and looking at the slide, we can see the scale of baggage fees compared to other sources of ancillary revenue. Now that airlines are collecting and profiting from this approach, doesn't it stand to reason that this service should be provided without any interruption? It's a matter of value, and at the very least, offer this with total transparency into how the bag is being processed and where it is at any given time. And so this capability exists through the use of RFID. And so that is the point. The point is to protect the ancillary revenue through better service when we check bags. And next slide, Tom. So before we move on to talking about the myths, I wanted to break here for a question. And I'm going to ask Lisa for help with displaying that particular question to all of you. I think all of you can see this off on the right side, and I'm going to go ahead and recite it if you don't see it. But based on the data that I've just presented, do you believe that baggage mishandling should be addressed using RFID technology? I'll give you all maybe 20 or 30 seconds to go ahead and help us with your answers. And maybe I can offer a little bit of narrative while you're thinking about that. Have you ever wondered why so many business travelers carry baggage on board? And being a business traveler myself, I can think of two main reasons. One, we don't want to lose the bag necessarily, and I don't want to lose that suit that I need for my meeting that afternoon. Secondly, sometimes it takes too long to reclaim the bag itself. So imagine a world where we don't see a delay because the overhead compartments are full. Something to ponder. Lisa, are we seeing results here?
Thanks, Mark. I'll push the results live in a few seconds.
Thank you. And there we see.
You should see the results now.
We do absolutely see it, yeah. Well, thank you for your vote of confidence, everybody. I think hopefully the messages are getting through. So thanks, Lisa, for the polling there. We'll maybe have one or two more of those as we move through. I'm going to go ahead and continue on now with the myths. We have presented facts and how effective RFID can be in removing baggage mishandling as a long-standing issue, but why haven't we seen a more widespread adoption? Why indeed? For one, there are a lot of assumptions and misunderstandings that still circulate. So let's talk about those. And thanks, Tom. So here they are, the top 5 pushback reasons we have experienced when talking about RFID adoption. And I'll go through these very quickly with you all, and you can read the narrative underneath. But the first myth, the biggest myth, is the cost of the tag is high compared to the paper tag that we use today for barcode. And that's probably true. The cost of the tag is higher. But ever since our primary initial installations at Hong Kong and Las Vegas, where we did see quite a gap between RFID tags and normal paper tags, thermal tags, the price has dropped to at or under 10 cents US dollars since that time. So when you consider the many benefits that you get on the other side, the cost of the tag more or less becomes irrelevant, because you easily recover the cost that you're spending on that tag for the downstream benefits. All that to say that the cost of the tag is high is in fact a myth for those two reasons. The second myth we've heard is that the read range is short. When it comes to RFID, we're used to optical scanners that reach across 3 or 4 meters on a conveyor belt. The fact of the matter is that the read range with UHF RFID or RAIN RFID is up to 10 meters. So really, with the infrastructure that we've got in place for optical systems, we're well within the range for very high read rate for RFID tags. The third myth, RFID readers have trouble in the bag room and the ramp. And we say that primarily because of all of the radio noise, so to speak, that we see in an airport environment. This is overcome fairly easily by performing a heat map and an analysis of any given airport location, and the frequency that we use actually for reading RFID is outside the realm of things like 5G and 4G and Wi-Fi and things of that nature. So really a misconception. The fourth myth, that the industry does not have a standard, couldn't be further from the truth. So before even IATA sort of passed this as a resolution to go forward with RFID, there was a subcommittee that looked into standardizing and making common the type of RFID that we're going to use within aviation industry. And so those metrics, those requirements, those definitions can be found in IATA's document RP 1740C. We are very much standardized across the industry that way. And then the fifth myth, RFID is not worth the trouble. Why should we bother if barcode gets it's a 95% read rate? 95% read rate with barcode is absolutely the very best that you can get. It's more like 90% or maybe even under that in many systems. So it is worth the trouble when you consider the difference between 99.5 and 95%, and I'll talk about it in just a second. We can move on to the next slide, Tom. Let's add a little humor, and on a humorous note, guess what other old quote-unquote technology took a while to pick up in adoption? That would be the internet, which took almost 20 years to be taken up as an existing technology who was finding its solution in the business world. And we very much see that in the case of RFID, all kidding aside, that this is technology that has now found a very viable solution within the business world. So that's the main point here. And the next slide, Tom. And then sort of finally, we're going to go ahead and talk about the myths that not just we as a commercial community see, but also IATA sees myths as well. I'll address these each. The myth is RFID isn't going to happen. The reality is it's happening. There are several locations now that have installed this. We have a major airline that's had it for 3 or 4 years. And I think Tom will address the expansion of RFID that you probably weren't aware of in his presentation. So it's happening. The second myth is RFID is a push by one single airline, that very large airline that's headquartered in Atlanta, Georgia. The reality is it's not, because Delta isn't even on the board at IATA. So it's not a push or politicized through that single airline. And as I demonstrated earlier in the IATA circles, many of the major carriers that sit on the board of governors unanimously voted this in without Delta. The next myth is that it's RFID or nothing. And if there's one message I hope you all take away from this presentation, it's that that couldn't be further from the truth, that RFID actually works quite well and complementary to barcode systems. Again, Tom will show you all how that happens and how that's a great way to achieve the absolute highest read rate we can get. The next myth is RFID isn't global. It is, in fact, global. It started in Hong Kong, went to Las Vegas, is now being used in some airports in Europe, so that's global. And then finally, the myth is that a new technology is around the corner. Well, that's an argument that can be made about iPhones, about computers, about many of the technology devices that we use day in and day out. But the point of the matter on this one is that RFID has been available for quite some time and is quite a mature technology. So therefore, you don't have the issues that you would find in the early adoption of other types of technologies. And then I think that's it for me, Lisa. I think if we could put up one more question for everyone to ponder, that would be great. And everyone, if you could look off to the right, Lisa, I'll go ahead and put up another question. It's a multiple choice. I'll recite it. What is the biggest obstacle that you feel is to RFID adoption? I'll give everyone 20 to 30 seconds. Go ahead and answer that one. Please be truthful. It's also a chance for you to get to take a break from hearing my voice.
There's about 10 seconds left.
Thanks, Lisa.
And now I will push them live in 1 second.
Thank you. Okay, I think we're all seeing the results. Lisa, thank you. I personally, I'm a little bit delighted and surprised, but I hope that everyone being on board here today, we're able to help you with that selection deal, lack of understanding, and certainly open ourselves for any subsequent questions later on, and beyond that, contact with Tom and myself. So without any further talk from me, I'm going to go ahead and pass the baton over to my colleague, Tom Gebler. Tom, all up to you.
Thank you very much, Mark. Appreciate it and appreciate the setup. What I'll be talking about is RFID, the what, how, and where. What we'll be discussing during my section is RFID airport trends that we're seeing, how the RFID tag is encoded to the IATA standard, IATA RFID systems and baggage handling, and then RFID opportunities in baggage handling with IATA 753 compliance, which we'll talk about in just a little bit. Generally, what we've been seeing is that the initial installations from McCarran Airport in Las Vegas and Hong Kong serve for the prototype for future open systems that we are seeing today. The developments that they created helped to generate a standard that would then be interoperable or readable across the world, which was a big benefit. Then we've seen Delta's rollout of RFID tags really seem to jumpstart the effort, and then combined with IATA's Resolution 753, plus falling tag prices, have airports implementing RFID at an increasing rate. When we talk about IATA 753, that's a resolution that has to deal with change of custody tracking between passenger to airline, when the bag goes onto the aircraft, when the bag is delivered to a transfer area, and then when it's returned to the passenger. Airports and airlines can also choose additional tracking points for IATA 753 compliance, and we have some solutions for that. The other thing we seem to be seeing a lot of is airports who are implementing common use systems where it's a standardized ticket counter system, for instance, or curbside check-in system. They seem to be pushing RFID most from what we've observed. And then what we're seeing is that RFID encoded tags are a key enabler for very high read rates, as Mark discussed, for baggage sortation. And as the bag moves from before and after TSA transfers, main lines, and outbounds, and also the ability to then add low-cost RFID waypoints that track baggage progress and denote changes of custody. For instance, when the bag is transferred from the the passenger, to the airport or the airline, you can have a low-cost reader there to denote the change of custody at the ticket counter curbside check-in as the bag travels to the makeup units, where they will be accumulated for transfer to the plane, transfers from plane to plane, and then inbound systems. Luckily, IATA really had great foresight in creating the 1740C standard, which creates a uniform baggage or uniform encoding standard for the RFID tags. Specifies a universally used EPC Global or Electronic Product Code Class 1 Generation 2 RFID tag in the UHF range of 860 to 960 megahertz. This is a very standard tag that's been in wide use throughout the world for retail and supply chains for many years, and choosing that standard was pretty wise, is because there's a lot of infrastructure to make the semiconductor chips that go into the tag. Companies like Avery Dennison, who further convert the RFID chips into inlays that are then put into the end bag tag. So the infrastructure is there. They really chose a good standard to go by, a very good RFID system. And then you have the IATA specification for encoding of the data in such a way that anybody with a properly configured reader can then read the 10-digit license plate that's on the tag, as well as the Julian flight date. So this means that no matter where the tag was created, it can be read wherever the tag is, as long as the tag followed the IATA encoding standard, which we'll talk about. Let's dive a little bit into the acronyms we had here. The 10-digit license plate number is essentially the same 10-digit number that you see on the outside of your bag tag today. When you check in your bag, a baggage source message, or BSM, is created that is then used to track your bag throughout its bag journey. So it lets the airport control systems know where to sort the bag for a particular flight, as well as if you're going to bag is going to transfer from flight to flight. The BSM stays with your bag, and that 10-digit number that you see on your on the outside of your bag is the same 10-digit number that's encoded into the tag itself. And so the BSM then becomes the index to the database that allows you to track your bag throughout its entire journey. Then we encode in the EPC memory bank and the RFID inlay, tag inlay in compressed form. Also, you have the Julian flight date, which is very convenient. Essentially, the Julian flight date is a 3-digit representation of the day of the year, represented on the day your bag is, your BSM was created. And the Julian flight date helps to separate your bag from other potential bags, because the license plate numbers tend to roll over because there's only a certain amount of them available at any given time. So the Julian flight date can be used to help identify your bag from another bag that has a similar license plate number, but a different Julian flight date. It doesn't occur very often, but it is certainly a possibility as, again, the license plate numbers roll over. Additionally, you have something known as a TID, or tag identification. That's a unique 96-bit serialized number encoded at the time of manufacture. and it's stored in a separate memory bank on the chip itself. And it can also be associated with a license plate number. But what's the key takeaway there is the tag identification is unique. Every semiconductor, RFID semiconductor, has a unique serial number that is not repeated. You also have the application family identifier, or AFI. The AFI is used in the encoding of the tag to tell the reader that what follows, the data that follows, is an airline tag as opposed to a EPC, or electronic product code. So that's an important differentiation. As we see tags moving through the system, it's not unusual to see electronic product codes within bags. Let's say somebody bought a pair of jeans here and they're traveling home. We can see those electronic product codes, but we know they are not. Airline tags because they do not follow they don't have the AFI, or application family identifier. So that's a key way we can tell and actually ignore codes that have electronic product codes on them, or bags that have electronic product codes inside them. Take a little bit deeper dive into the actual encoding structure. So if my bag license plate number is 6006538 007, as we see in the bottom, it will be encoded and compressed into hexadecimal on the tag itself. And then you see the first two digits of the encoding are 0C. So that's the application family identifier. That tells us that this is specifically an airline tag. And then we have the next couple of fields are used to tell the reader how the license plate number was encoded, how this hexadecimal information was encoded on the tag. And then we follow a similar schema for the Julian flight date that says, okay, that what follows is the Julian flight date, and here's how the data was compressed. So the readers will then decompress the tag from the hexadecimal format to the 10-digit ASCII that we normally see, the 10-digit decoded license plate, as well as the 3-digit Julian flight date. There's several ways you can actually use the tag. Generally, everybody's using method number 3, but you could have the tag only basically just use the application family identifier as well as the tag ID and associate that with the bag. But then you won't have the license plate number associated with it. So then you have the next step up is to associate the tag ID with the license plate number. And then number 3 is what we see in the IATA standard, where you have the license plate number and Julian flight date encoded in the tag and then associated with the tag ID. And then finally, you have encoding of potentially additional data on the tag itself. Could be some additional passenger data, although currently nobody is using that right now. In Delta's case, the tags that they use have enough memory to store the Julian flight date and license plate number, but no additional memory. In terms of what, you have RFID used for sortation, and one of the good things and bad things about RFID is that not necessarily directional. That means that as the tag moves through the RFID reader's antennas, the cloud of energy generated by the antennas excites the tag, and then the tag gives up its data. One of the things about RFID is it's very well possible to read multiple tags in the field at the same time. And when you're sorting bags to the outbound systems, it's critical to make sure that you are always associating the correct tag with the correct bag, even when the tags are spaced down to 16 inches, which often occurs when you have bags that might be separated by, let's say, 30 inches physically, but because of the length of the tags and the way they lay on the belt, it's not unusual to have tags that are actually fairly close to each other. And we use specialized systems and antennas and tracking algorithms to make sure that we associate the correct bag to the correct tag in the same way we do with barcode tags. And here you see two basically different solutions. On the top, you see a system that combines RFID with laser scanning, And on the bottom, you see a system that incorporates RFID panels with camera scanning. Here's a case where we've actually taken the RFID panels that you see on the left and then integrated them into a existing laser-based tag reader to create a hybrid system that is then also uses the same redundancy concepts that we use on our other arrays, which means that no single point of failure will bring down the array. And then we basically integrate these two together, and now the airport can read both RFID tags and barcoded tags interchangeably. In terms of how, we look at RFID for IATA 753 compliance, and there are several ways you can use it. One is by, again, using low-cost waypoints, which are just RFID-only readers. So when the passenger turns over the bag to the at the ticket counter curbside check-in, simple RFID reader after the bag is passed off into the conveyor system then denotes that change of custody. Then as the bag moves through the process in the airport baggage handling system, you can add another waypoint to determine that the bag has made it to the makeup unit where bags are accumulated with other bags to go into the plane. This is a way of tracking tracking the bag through the processing steps where it's being screened by TSA and other sortation. Make sure it's on its way, and if a bag hasn't reached planeside that is supposed to be there, then this gives the airport and airline a way to go back and look and see where's the last time that bag was recognized by an RFID reader. As the bags go on the plane, they could be read by a RFID-equipped handheld, or potentially a RFID system added to what's known as the belt loader, which are the small conveyor systems that you see, mobile conveyor systems that you see rolling up to the plane. It's possible to outfit the belt loaders with RFID or use a handheld scanner. And in the same way as the bag coming off the plane, it can be read with a handheld scanner or with the a belt loader, RFID-equipped belt loader. And then finally, the final step of the bag's journey is when the bag is placed on the conveyors that then take it to the claim carousels where we all pick up our bag. It's very simple to put a RFID waypoint on that conveyor to then say the bag has reached the end of its journey. It will be retrieved by the customer shortly. Those can either, again, be a standard RFID only waypoint, or it could be added, RFID could be added to what we call inbound systems that we have installed at some airports currently. You can see here, there are a couple of examples of RFID units used for waypoints. In the top picture, you see a RFID unit that's basically scanning the bag as it's moving in its final part of the baggage handling sortation system to the makeup unit where it's accumulated to go into the plane. And then the bottom one, you see a simple RFID unit used to track the change of custody after the ticket counter or curbside check-in feed. And again, these are just RFID reader only systems. They can be placed at a lot of places in baggage handling system for a much lower cost than we might charge for a full-blown optical system. In terms of where, we've seen quite a bit of activity on RFID, and really a surprising amount of them installed right now. So Salt Lake City will probably be one of the largest airports with RFID for sortation as well as inbounds. Atlanta has RFID integrated to an existing barcode array. Baltimore, the D&E connector has our barcode RFID hybrid. Love Field in Dallas has a very complete RFID system where using waypoints for ticket counters, feeds, curbside check-in, RFID waypoints for the makeup units, barcode and RFID hybrids for security feeds, and then our barcode and RFID hybrids for their outbounds and main lines. Raleigh-Durham, we just installed some camera and RFID-based hybrids there. Buffalo We'll be installing hybrid inbounds there for their IATA 753 compliance effort. Newark Terminal A, Orlando Terminal C, LAX Terminal 2-3 upcoming, LaGuardia Midfield. These are all airports that are slated to have RFID systems installed. That's all I have for today. I will turn it back over to Lisa. I want to thank everybody for participating, and we'll open it up for questions.
Yeah, thank you, Tom and Mark. We'll go ahead and take some questions. So as a reminder, please type your questions into the Q&A section on your right-hand side of your screen. But Mark, it looks like we have some questions first regarding your part of the presentation. And one of these questions came in the beginning, so around slide 6, what a attendee asked. Can you expand about the comment on finding an individual bag in a pile of 300 bags? How does that work?
Sure. And thanks for the question. So typically, you would have this pile of many bags, just pick the number, but it's the result of misconnections due to an IROP situation. And I'm trying to find a hot bag so that I can make a connection. And the only way that I can do that today pretty much is to use a handheld laser scanner. And in order to do that, I have to go through the bags one by one, which can take several minutes. In the case of RFID, there is a capability on the handheld devices called locate. It's a kind of Geiger counter-like feature that will home in on an exact bag tag when you type that bag tag number into the device. So it's sort of like a hot-cold indication, both in terms of audio and visual cues. So as I move my scanner around, it tells me yes, no, and the closer I get to the bag, of course, the higher the pitch, and then the more bars I get. And once I find the bag, which will probably take anywhere between 1 and 2 minutes, it's very accurate in terms of how they do that. I hope that answers the question.
That same sort of concept can be used to locate bags on the plane itself, in the belly of the plane. Let's say there's a bag that has to be pulled off the plane because there's a question if it's a valid bag for that plane. Much easier to use the Geiger counter function to then go find a bag that's already been loaded within the belly of the plane, just by having the bag handler sort of move down the row of bags to then find the tag that you're interested in.
And if I can just clarify one point, Tom, thanks for that. Maybe make it even more understood. When we use, of course, barcode scanning, we rely on line of sight, which means I have to be able to point that laser beam to a tag through that light source. And so if there's an interruption to that, meaning the bag is in the middle of the pile, then I have to uncover all the bags so that I can finally get the line of sight, where in fact with RFID, that's not needed.
Great. Mark, I'll ask you another question. What is the timeline for the industry standards organization to push towards tags with RFID and barcode?
Well, if we go back to the resolution that came out of the IATA Board of Governors in 2019, the stated goal was earlier on was to do this in a short amount of time, but from an industry-wide adoption goal, something in the order of 4 to 5 years was what we were talking about when that resolution was passed in 2019.
Awesome. Tom, I'll ask you a question now. With regards to the Julian date, can you explain what happens during leap year?
That's a good question. I guess I'm not entirely sure, but I would believe that then you would have 366. You would have a valid 366 days within the year. But I guess I've never pondered that. But I would assume that you would have a 366 date or day in the year that in that case.
Tom, another question for you is, what happens after the tags are used? Is RFID recyclable?
The tags could be rewritten. they are not locked. There is a provision to actually lock the tag, meaning once the tag is written, it can't be changed. The tags could potentially be recycled, but you have inside the tag itself is the inlay, which would be, I think, fairly difficult, or if not impossible, to pull out of the tag. Mark, do you have any comment on that?
I absolutely do, Tom. Thanks for the invite. I think the question comes maybe from a sustainability point of view, and there are products that are coming to market that would replace, in many cases, a single-use or consumable bag tag, a paper bag tag, and they come in the form of electronic bag tags, or EBTs, or PBTs, and this has been pioneered essentially by Qantas in the past with their Q tag, but that is the solution going forward to reusing essentially a bag tag per se. And so the notion or the functionality of an electronic bag tag, an EBT, mimics what a paper tag does, both in terms of its capability to display a barcode on its screen. It's a mini screen that you put on the handle of your suitcase, and then within the casing there is that very same RFID inlay that you would find in the paper tag. So it's reusable over and over and over again. Pretty much a permanent bag tag number assigned to you as a frequent traveler, let's say.
I think the question also was not only sustainability, but also like ID theft or security. Is if the tags are reused, how does that affect? Like, what about ID theft or security after they're being used?
So, go ahead, Tom. Sorry.
Well, I guess one of the things I'll kick it off by saying the tag itself, the encoding of the tag itself, only contains the 10-digit ESM or license plate number. Once that number doesn't directly identify you unless you have access to the airline database, the databases, and that is something that nobody really has unless you're within the baggage handling system. So in general, there's no personal data that's physically on the tag, encoded on the tag. That I wouldn't worry about. Again, it would be possible to rewrite the tag if it wanted to be reused, or as Mark is saying, and I think you will see some very interesting things coming out from Avery on reusable tags that would be assigned to you, much like the Qantas Q tag, as well as other tag technology that's coming out on the marketplace.
Right, Tom. I wanted to comment in pretty much the same way you did, and that is there really is there's no data that's placed and encoded on an inlay today that would in any way connect to an individual, like a frequent flyer number or flight data, things like that. So and unless you had the ability to connect all the way back to back-end systems like departure control systems or reservation systems, you would not be able to associate a bag tag number to a given passenger, and therefore, privacy issues.
A common question I'm seeing, especially now with COVID-19, is about a touchless approach. So the question is, how does baggage handling change if the touchless approach increases? And how does RFID help with that?
So if I can answer that, Tom, first, if you want to chime in a little bit later, but we're back to what I explained a little bit earlier in terms of the use of electronic bag tags. That's going to give you the capability to go ahead and completely check in at home. Whereas today, there's some options where you can check in and you can print your bag tag essentially on a piece of paper on your inkjet printer, but you'd have to put it into a sleeve on the bag itself and so forth. But there is now a capability where you would completely avoid, let's say, having to work with an agent at the airport to tag the bag. in the form of that electronic bag tag. So, using the app that's given to you by the airline, not only can you go ahead and check in and secure your seat and so forth, you can check your bag by using NFC, capability to communicate with that electronic bag tag and download essentially the new bag tag number that you'll use that day. Tom, if you wanted to add to anything of that.
Yeah, one of the things I wanted to mention is that one of the trends we're seeing here in the United States, and actually been very common in Europe, is the idea of a self-bag drop, meaning when you go to the airport, instead of going to the ticket counter, you would go to basically a station where you would show your identification in the form of a passport or potentially your Real ID compliant driver's license, identify yourself to the system, put your bag in the system, and then have it the system generate a tag that you place on the bag, put it on the handle, and it basically gets inducted into the system, and that without actually ever having to see a ticket agent. The TSA has been relaxing its rules. In Europe, we found self-bag drops to be very common, and we're now starting to see those to be much more common in the United States due to some flexibility that TSA has implemented. And Denver Airport will be implementing a very large number of self-bag drops. And we just saw recently Spirit Airlines was buying automated self-bag drops, and we're seeing a lot of that activity, which then could help the idea of contactless drop-off. And then potentially also, as Mark was saying, with if you've got your own reusable tag, to do that at home with a phone app, which I think is a pretty exciting development in my mind.
Awesome. This question would probably be for both of you. Is would there be any issue if a passenger carries an RFID blocking bag?
If they have, if the RFID tag is in a blocking sleeve, then we won't be able to read it using RFID. If they don't block the barcode, then there's a chance we could read it with the barcode portion of the system. However, for the RFID waypoints, then it won't be readable. So I guess the idea is, yes, if you put the tag in a blocking sleeve, we won't be able to read the RFID. Nobody will, but then you've sort of defeated the purpose. I will encourage people that as we move to increased RFID tagging, to take their old RFID tags off their bag and not store those in the bag themselves. We see that happen where we'll see multiple tags in a bag, and we have to look at the Julian flight date to see if it's a current tag. And then the baggage handling system will look up the license plate number to make sure it's current. But sometimes we could see 2 or 3 tags that people have just stashed in their bag from previous flights, and we will read them. So we have to be a bit clever about how we process those tags. And generally, we can use the Julian flight date to throw them out. But I will encourage people to not leave old RFID tags in their bag if you can avoid it.
Great. Mark, I have a question for you. And the question is there maintenance required on RFID readers?
Sure. There is some degree of maintenance, but I will say that it's far less frequent than you would have with optical scanners, with laser arrays. Dust and alignment and things like that aren't as critical, really not critical at all. In that harsh environment we call a bag room, which is another reason why RFID is a good choice. And so the sort of recurring and the ongoing maintenance cost is something we factor in when we talk about an ROI when you decide to go ahead and implement RFID tags. So quick answer to that is there's far less maintenance and less frequency to servicing RFID scanners and readers and so forth. And Tom, I mean, I know you guys deploy these, so I'll go ahead and.
I would agree with that. I mean, basically, the RFID portion of the system is entirely solid state, very, very reliable. The portion of the system, the optical readers are going to need some occasional preventive maintenance to keep the lenses clean and such. But the RFID, there's really not much in the way of routine maintenance on them. They will gather dust in the bag room. That really won't affect the performance. And again, since it's solid state, there's really no moving parts in the RFID subsystem to wear out. So it's something that we anticipate lasting a very, very, very long time.
I mean, I've seen instances where once you calibrate the readers and then you get the right distances and the right implementation, you don't touch them for years sometimes.
Yeah, I agree with that. And we typically we have arrays in baggage handling systems that are 15 or more years old, and our oldest system here in the United States is probably 3 or 4, and there's never been any maintenance on it that I recall.
Great. Well, the list of questions keeps on streaming in, so I'll ask you both 2 more questions, and then all the questions that have not been answered, I'll share with Tom and Mark, and they can contact you directly to make sure your question is answered. So one of the last questions is, are tags being encoded at manufacturing plants or at the airport?
I'll go first, Tom. So there are, and Tom did a great job in his presentation, I thought, of explaining the components of what you find on a given chip that's a part of an inlay. So some components are hard-coded when they're manufactured. So the TID, which is a unique identifier to every single chip ever made, is an example of that. So that's hard-coded when it's manufactured and stays with that particular device, that IoT device, for its entire life and never to be duplicated. And then there are certain panels or banks that can be completely encoded, which when Tom explained to us, the license plate, the bag tag number, if you will, that's always going to be encoded. And then if you go to, I don't know if you all recall the 4th option Tom presented on encoding RFID inlays, you have user banks where you can put in selected information optional to maybe your own operation. So, airline A may want to not do anything but the license plate number, and airline B may want to add and supplement data to the license plate number, such as a destination code or frequent flyer code or something like that. That's sort of optional to that particular airline and can be encoded at the time that the bag tag is deemed active. So when I check in and the bag tag is either printed or encoded at that point.
I guess I'll expand on that a little bit, is that I believe the tags, when they come from the inlays come from the factory, they are generally blank encoded to the EPC standard. It is possible for the manufacturer, the label converter, to then put the application family identifier in there with the rest of the information blank, so that tag can be identified uniquely from an EPC tag. When the tag then goes through the printer, the combined RFID and barcode printer, it is then encoded with all the IATA information. I guess one of the things we didn't talk about is that a lot of the current barcode-only printers that the airlines are using are actually retrofittable with a small module, so that tag printer can then become an RFID printer. So most of the printers, I think, purchased in the last, what would you say, Mark, 3 or 4 years, could be then upgraded to with an RFID encoding module.
Right, field upgradable too. Mm-hmm.
Field upgradable, correct.
All right, last question. What roles do you see computer vision or machine learning having in conjunction with RFID usage within airports in the future?
I'll go first, Tom, if I may. I would say that the ability, that's a great question, because it feeds into the future of things we're going to need in our environment, you know, when you talk about AI. So how does AI actually work? It's the fundamental data that gets collected at the with the edge devices, and I would consider an RFID tag of any sort to be an IoT edge device that would feed such systems with the necessary data that you're looking for. And I think Tom had it on one of his subsequent slides that you can have multiple, you know, read points to provide those systems with, you know, many different tracking points that does nothing but enhance, you know, the data that you're receiving about about the location of the bag and the timing and all these sorts of things, which can then be fed into, you know, larger systems regarding the overall operation. So I think that, you know, when you consider the rich data that you can extract or provide with these IoT edge devices can do nothing but strengthen, you know, those capabilities.
I would agree with that. I think ultimately RFID and AI, for instance, will be complementary technologies or they'll enhance each other. I don't necessarily see one replacing the other, but I do see applications in the future where there could be a combination of those technologies that'll make baggage handling easier, faster, more reliable, and, you know, hopefully less expensive.
Awesome. Thanks again, Tom and Mark, and thank you to our attendees. Unfortunately, that's all we have time for today, but like I mentioned before, all your questions will be answered by Tom and Mark if we didn't get to them. And we hope to see our listeners again soon. On stick.com, we have a list of our upcoming webinars, and we hope to see you again. Thanks again.
Thank you, everybody.
Thank you.